All right, I'm back to finish this off. I did also realize that all the time I've been a teacher, every time there's a nice day, the kids in the class always says, "Hey, can we go outside for class?" And I always say no. But you know what? I took you outside for class today, so don't forget it. It's happened. We're outside. Check this out. You can see trees and blue sky and sun, and I can't hardly see. I'm blinded myself out here. So just remember, I did take you out for class today. And so now I've done it, I've accomplished it. We don't have to worry about asking about that anymore. All right, going back to sampling example, we talked about with replacement, without replacement. Now we're going to talk about how we would calculate those probabilities. So these are just repeats of those same two diagrams. If I was interested in finding the probability of getting 2 red marbles in a row with replacement, I would take 3/6 times 3/6, and because it would be a red and a red. And I would multiply those, and I would get 9 over 36, which reduces to 1/4. And if I was interested in the same exact thing, but over here without replacement, then the first probability is 3/6, but that red, again, that red is gone. So now there's only 2 reds out of 5 left, so it would be 3/6 times 2/5. So that would give me 6 over 30, and 6 over 30 reduces to 1/5. So notice that those final results are different depending on whether you put it in or you don't put, you put it back or you don't put it back. So we're going to look at an example, and then you're going to try one, and we're going to be done. I have a box that has 3 red, 2 blue, and 1 yellow. So again, that's 3, 4, 5. That's a total of 6 in my box. And I want to find the probability of getting 2 different colors with replacement occurring and if replacement does not occur. So here's my situation. Red, there are 3 out of 6. Blue, there are 2 out of 6. Yellow, there's 1 out of 6. And I want 2 different colors, so when I look at all my possible outcomes, this would be a red and a red, and that's not 2 different colors. This would be red and then a blue, red and a yellow, so these 2 would be different colors. Blue and red, 2 different colors. Blue and blue, not 2 different colors, so I wouldn't count that one. And blue and yellow, so you can kind of see the pattern going there. So if I'm interested in getting 2 different colors, all these ones with checks would be the outcomes that would yield 2 different colors, which means this would not. The blue and blue and the yellow and yellow, none of those would work. So to get my answer for if I put the marble back, again, these are the same probabilities of after I take a 3/6, I take a red one out, I still have a red one. And I could get each of these outcomes by multiplying along the branches, and that's with replacement. So I actually didn't answer the question here. So I'm going to do the multiplication. So 3/6 times 2/6, and then I'm going to have 3/6 times 1/6. I'm going to have a lot of these. That's okay. So this would give me 6 over 36. And again, I'm not going to reduce until the end because I know I've got to have a bunch of 36s over here. So that was that one. Now I've got to do this one. It would be 2/6 times 3/6. So it would also be 6 over 36, and then I would, so that's 1, 2, 3, 1, 2, 3. I'm on this one, so it would be 2/6 times the 6th, which is 2/36. And then I've got this one, which is a 6 times 3/6, which is 3/36. And I've got one more to go, and that would be yellow, blue, so it would be 1/6 times 2/6. That's 2/36. So because any of these could happen, it could be red and blue or red and yellow or blue and red. I need to add all of these up. So because they all have a common denominator, I know it's over 36. So I have 6, 7, 8, 9. 9 plus 6 is 25, 26, 27, 28, 29, 30, 31, 32. If I added those up correctly, which I'm not sure if I did or not. So 6, 9, 15, 17, 22. 22 over 36, which will reduce to 11 out of 18. So both those divide by 2. So there's the chances of it happening if I put it back. Now if I play the game where replacement doesn't occur, I've now changed all of these probabilities on the second side of it. They're all now denominator 5, and if I chose a red, it knocked the red marble out. But again, I want different colors. So again, I don't care about this one. I don't care about blue outcome, and this can't happen. We talked about that a minute ago. This can't even happen. So all these ones that aren't scribbled out are the ones that can happen. And so again, if I want to calculate those probabilities, I'll try to do it a little neater. It would be 3/6 times 2/5. And usually I try to do these right here, but I can't write that small with this device, so I'm kind of spreading them out a little bit. So that would be 6/30. See how I made that little mental error? Boom. Then I would have 3/6 times 1/5. So you'll notice that what's happening is in all of these my denominator is changing. I would have 2/6 times 3/5, which is 6/30 again. And I've checked that one off, and that one, and that one. Now I've got to do this one, which is 2/6 times 1/5, which is 2/30. Check it off. I've got moving to the bottom one, which is 1/6 times 3/5. And I have one more to go, and I'm going to check it now because it's 1/6 times 2/5 equals 2/30. And again, it could be any one of these as my outcome of two different colors. So I'm going to add up all of these outcomes. My denominator is 30. And so 6, 9, 15, 17, 22. The numerator stayed the same this time because by taking a red out, when I go to a different color, it didn't change that top number for blues, because the fact that there were two blues didn't get impacted by the fact that I chose a red. But the denominator did, because there's one less marble. And this would reduce to 11 out of 18, so a different answer again. All right. You're going to do the same thing. You got 2 marbles in succession from a box. You've got 2 purple and 5 green. And you're going to find the probability that your marbles are different in color. You're going to do it 2 different ways. One, if you take after you've checked the first marble, you put it back. And then you're going to do the second way where you don't put it back. You've taken out your first marble and you put it in your pocket for whatever reason and do the second one. So pause this thing and give it a go. The slides falling all over. Working outside, my notes right here blew away, and I couldn't see, because usually I thought I had the answers pre-programmed in this bad boy down here in the corner, and they didn't show up, so I wasn't sure what was going on. I was trying to find my slide. I don't know where it went. Probably got melted by the sun. Anyway, if you replace the first one, I did this all out on paper, so you try 3. If you replace the first one you draw and put it back, you should have ended up with, let's see, 20 out of 49. The first answer should have been 20 out of 49, because you had 7 total, and no matter what, on the second draw, you're still going to have 7. That's how we get 49. If you did not put it back, then that second marble, you're only going to have 6 to choose from, and so that's going to change things. And I ended up with 20 out of 42, which I reduced to 10 out of 21. So these were the 2 answers. There they are without the tree or the calculations. So again, if you need calculations or look at a tree, please let me know. I guarantee I have it. Boom. So I could share it with you. So post a message or email me. That's it. So this video is, I told you, going to be shorter than the other one. So yay. Have a good one. Enjoy the sun.